Lowe's knows that no matter your paint project, saving is at the top of your list. That's why when you shop today, you can buy one, get one free select Valspar and HGTV Home by Sherwin-Williams one-coat coverage interior paints via rebate. Shop these deals in-store or online today at Lowe's. We help, you save. Selection varies by location. While supplies last. Discount taken at time of purchase. See sales associate for details. Offer valid 8/21 through 9/3.
Welcome to the Deep Dive. Today, we're really getting into AI safety testing. Specifically, we're looking at a pretty groundbreaking new way to red team large language models, LLMs. Our mission here is to pull out the most important insights from a really fascinating conversation with Bret Kinsella. He's the GM of Fuel and IX at TELUS Digital and his team's research. And, there's a real aha moment coming up. Understanding this new approach to AI safety could honestly help you navigate generative AI no matter what field you're in. You'll find out why the usual security checks for AI, they're kind of like trying to catch smoke. And we'll explore this really ingenious solution that's changing the game.
Yeah, and it's so critical right now. I mean, AI adoption is just accelerating everywhere, isn't it? And with that speed comes new risks, often ones people didn't quite expect. So proactive safety testing, it's quickly moving from nice to have to absolutely essential.
Okay, great point. So with that context set, let's maybe start by unpacking Bret Kinsella's background a bit. It's pretty remarkable. He's been a key voice in AI for years, but his work with new tech goes back, 3 decades? Internet, RFID, mobile, the whole lot.
That's right. And what's really interesting is his consistent focus throughout all that time on the drivers and the barriers for technology adoption.
Exactly. It really frames how he approaches AI. And he's been deep in the AI space specifically for, I think, over 12 years, working with conversational AI, NLP, NLU.
Yeah, the stuff that lets computers actually understand human language,
Right.
way before generative AI became, the buzzword it is today.
And his research businesses, VoiceBot.ai and Cynthia, they were also key in figuring out AI adoption rates, market shifts.
Mm-hmm. And it's fascinating how all that experience, especially with big companies, large enterprises, led him to TELUS Digital about, a year and a half ago?
Right. And TELUS, being Canada's biggest telecom, they had this internal need, right?
Absolutely. They'd built their own generative AI tools, like the Fuel IX copilots, for their own teams. Huge company, 75,000 employees, massive contact centers. They needed robust internal tools, but then their customers started saying, hey, can we get access to that?
So Fuel IX grew from an internal tool to a platform they offer externally, too.
Exactly. It's now their generative AI platform and applications used inside TELUS and for their clients, which, kind of proves it works.
So for you listening, maybe you're leading a team, maybe deploying AI. What's the actual tangible impact of something like Fuel IX?
Oh, it's huge. Because these tools, Fuel IX copilots, for instance, they're general purpose, sure, but the real magic is in the customization. When you ground them in your own company data, add search, use really specific prompts, that empowers your frontline folks.
Not just the developers or the data scientists.
No, exactly. People in finance, HR, marketing, IT, contact centers, even security. They're finding real efficiencies, fixing broken processes they already knew about, finding new ways to improve things. It's quite powerful.
Okay, that sets the stage really well. So let's zoom in now on the specific challenge that sparked this new research. AI safety and this idea of red teaming for these, very different AI systems. Now, for anyone familiar with cybersecurity, red teaming isn't new, right? Security experts basically act like attackers.
Mm-hmm. Trying to break in, find weaknesses before the bad guys do. It's like a controlled attack simulation.
And then blue teaming is fixing those weaknesses.
Yeah.
And continuous red teaming has become standard practice.
Right. But AI, especially generative AI, throws a real curveball into that whole process. It's more than just traditional security. We need to be clear about the difference between AI security, protecting the system itself, and AI safety.
Safety being about preventing the AI from doing harmful things on its own, like generating biased content or just making stuff up.
Exactly. And that's a huge focus for regulators. The fundamental issue with generative AI is its unbounded inputs and outputs. Think about older systems. They were programmed, limited actions, defined results. Predictable.
Like a vending machine. You put money in, press a button, get a specific snack.
Pretty much. Or even older NLU systems like Siri or Alexa. They had unbounded inputs. You could ask anything, but the outputs were usually pre-approved, limited actions. Generative AI, though, it's probabilistic. It makes predictions. The outputs aren't all pre-approved. They're variable.
Which leads to things like hallucinations or pulling the wrong data.
Precisely. And that's where guardrails come in. These
Right.
are reactive technologies, input scans, output scans, rules, maybe even little AI agents watching over things. They try to catch problems as they happen. But, and this is key, they're also probabilistic defenses.
Meaning they reduce the chance of something bad happening, but they can't guarantee it won't.
You got it, because the AI itself is inherently unpredictable at its core.
Okay, and this is where Kinsella's research really hits home. The problem is we've got this explosion of AI co-pilots and bots, but the number of skilled human red teamers just hasn't kept pace, not even close.
Right, there's a huge gap, a massive demand for automated solutions. But the existing security tools, they were built for those older, predictable, programmatic systems.
They aren't really designed for the, the wild west of unbounded natural language that LLMs use.
Exactly. So companies are often stuck relying on human testing, which can't scale, or these limited AI tools that don't really grasp the nuances.
And this leads to the core flaw they identified, right? The simple pass-fail test.
Yes. This is the crucial insight. Kinsella's team found that the very same prompt, delivered multiple times to an LLM, can give different results regarding vulnerabilities.
So an attack could work sometimes, but not others, using the exact same method.
That's it, because the LLM is probabilistic. It might resist a malicious prompt 5 times, and then on the 6th time suddenly fail. It means a single binary test, did the attack work, yes or no, is just insufficient. It doesn't tell you the real risk.
Wow, okay. So you need to test repeatedly at scale to get a true picture, like looking at the whole landscape, not just one spot.
Exactly, like multiple cross-sections. This is directly tackling that real-world problem you hear about these sophisticated prompts tricking systems into revealing secrets. You have to understand the probabilistic nature to defend against it.
That does sound unsettling. If an attack can slip through randomly, how do you even secure that? So, given this pretty fundamental flaw, what did Kinsella's team develop? You mentioned OPRO.
Yes, OPRO, optimization by prompting. The core idea is pretty clever. Let an LLM effectively red team itself.
And AI testing an AI.
Sort of, yeah. It overcomes those human limits of scale and, frankly, creativity in attack methods. The system has 3 main parts. First, an attack model. That's an AI specifically designed with attack goals, methods, techniques.
Okay.
Second, the target. That's the AI system you're testing, the bot, maybe with its own rules or code of conduct. And third, a judge model. Another AI that evaluates the inputs from the attacker and the outputs from the target.
And what makes it different from just, throwing lots of automated tests at the target?
It's the feedback loop, the optimization. It's not just static attacks. The judge tells the attack model what happened. If an attack fails, the attack model doesn't just stop. It modifies the attack. It tries a different technique. It actually generates novel attacks.
Ah, so it learns and adapts its attacks.
Precisely. Humans can only run so many variations, think of so many weird edge cases. OPRO can run thousands of novel attacks in minutes. They mention like 3,000 attacks against one bot in a single run.
That's a lot, like a tireless, incredibly creative cyber ninja team.
Kind of. And the output isn't just pass-fail. It's a detailed blueprint of vulnerabilities. They categorize them, I think, into 15 types and pinpoint exactly what kind of weakness it is within that category.
And that blueprint tells you where to focus your defenses.
Exactly. Where to put stronger guardrails, maybe tweak your prompt engineering, add supervisor agents, or even change the training data. It's proactive. That whole ounce of prevention idea. You find and fix the holes before they cause real problems.
So it's not just automation. It's this dynamic, self-improving attacker AI. That feels like the real breakthrough. You're not just finding known weak spots.
Yeah.
You're discovering how your AI might be exploited in ways a human might never even consider. But okay, if pass-fail is out, how does OPRO actually give a better measure of risk?
Right. So instead of that binary yes-no from one try, OPRO calculates something called the attack success rate, or ASR. But it views ASR as a distribution.
A distribution, how does that work?
It runs the same attack and variations of it many times, very quickly, seconds or minutes. Then it calculates the exact success rate based on how often that attack objective or attacks in that vulnerability category actually succeeded across all those attempts.
So you get a percentage likelihood based on many tries rather than a single snapshot.
Exactly. It's a probabilistic measure for a probabilistic system. It gives you a much, much truer sense of the actual security profile, the real likelihood of a specific type of attack working.
This really does sound like a game changer, especially, like you said, for high-stakes areas, finance, healthcare, energy. So how should companies in those sectors change their testing based on this? What's the first step?
It really boils down to three things: comprehensiveness, repetition, and creativity. First, comprehensiveness. You need to go way beyond the standard list, like OWASP Top 10 or MITRE. They're good starting points, but they weren't built for generative AI's unique issues.
So use more attack types, like the 139 objectives Kinsella's team uses.
Yeah, something like that, covering those 15 or so categories. Plus, you need the ability to add your own industry-specific or even bot-specific concerns, maybe things from your company's AI ethics policy or code of conduct.
Okay, comprehensiveness. What else?
Second, repetition. You absolutely have to run these tests multiple times. One test run just isn't reliable, as we discussed. Get that statistical view. And third, creativity or ingenuity. The automated AI attacker isn't held back by human biases or maybe even squeamishness about trying certain types of attacks. It explores more broadly and deeply.
Makes sense. What about frequency? You mentioned good hygiene earlier. How often should this be done?
Oh, absolutely critical. Current practices, often just testing at launch maybe, that's nowhere near enough. These models get updated, the tools around them change.
Kinsella mentioned models updating maybe every 7 months, or even just changes in orchestration tools.
Right. So you need continuous automated testing. The recommendation is at least monthly regression testing, and definitely test every single time there's a significant release or system change.
Monthly at least. Wow.
Yeah, but the beauty of automation is that it makes this feasible. Even non-technical people, like product managers or project managers, can potentially run these tests. It gives everyone constant data. Application owners get confidence, security teams get a proactive blueprint for fixing things, instead of just constantly reacting with guardrails after something potentially goes wrong.
Okay, so better testing, more frequent testing, automated testing. But there's the other big factor looming over all this: regulation. We're seeing more rules coming out, like the White House AI Action Plan, EU initiatives. How does a method like OPRO help companies deal with that? How do they show they're being responsible?
That's a really important question, and something TELUS Digital deals with directly: being regulated themselves and serving regulated industries like government and healthcare. The truth is, many current regulations are still a bit ambiguous. They lack specifics on how to test, but everyone expects them to get more specific.
So companies need to get ahead of it.
Definitely. The smart move is to proactively set your own high standards for AI safety and security. Show you're taking your fiduciary responsibility seriously. You need that layered defense plan we talked about, and critically, you need to demonstrate you're addressing AI safety, not just security. That's what regulators globally are really zooming in on: preventing harm, reputational damage, and of course, fines.
Looking down the road then, what's the next big challenge? Where should researchers, developers be focusing their energy in AI safety?
Good question. I see a few key areas emerging. First, just continuing to develop more sophisticated vulnerability testing like OPRO. That proactive defense will always be crucial. Second, I think we'll see supervisor agents become much more common.
Supervisor agents,
Yeah.
what are those exactly?
Think of them as other AI systems, agentic systems, that essentially watch over the conversations or outputs of the main AI. Another layer of defense may be smarter than basic guardrails, but the real next frontier, and honestly there isn't a lot of focus here yet, is root cause identification.
Getting beyond just finding the vulnerability or the how, the guardrail to the why.
Exactly. Why do these problems happen in the first place? Is it something in the fundamental model architecture, the training data? If we can understand the root causes, we can make fixes further upstream, build safer systems from the ground up rather than just patching holes after the fact.
That makes a lot of sense. So for everyone listening, trying to innovate with AI but also do it responsibly, what's the single most important piece of advice you'd offer?
I think it has to be a three-part answer, really practical. Policy, technology, and process. First, policy. Your organization has to define what matters to you regarding AI safety and ethics. Go beyond just ticking regulatory boxes. What does being a good corporate citizen mean? How do you do right by your customers? AI governance is still pretty new, but it's vital.
Okay, define your principles. What about technology?
On the technology side, a key takeaway seems to be: narrow the scope of your model's instructions. Don't try to cram everything, like 10,000 words of rules, into one giant system prompt. Instead, consider using multiple models. Maybe one model focused on what to do and other models acting as governors focused on what not to do. Because sometimes models just seem to ignore the "don't do this" part if the context gets confusing.
Interesting. Use specialized models like a team. Yep. And the third part?
Process. And this circles back to what we discussed earlier. Regularly test your systems. Seriously, manual red teaming alone won't cut it. Basic automation might miss things. You need that periodic test, at least monthly regression testing, plus tests for any significant updates or releases. You have to proactively tackle these novel risks if you want AI adoption to really take off safely without causing unintended harm.
Policy, technology, process. That's very clear.
Hmm.
Well, thank you so much for breaking all that down. It's been a really insightful deep dive into AI safety testing. We really hope the insights shared today help you, our listeners, navigate the often complex world of generative AI in your own work. As we keep pushing the boundaries with AI, the message really seems clear. Continuous vigilance, that constant testing and improvement, it isn't just a good idea, it's fundamental for responsible progress. So maybe it's something to ponder further. What more can we learn about the why behind AI's unpredictable behaviors, and how can your organization start integrating this more rigorous, more continuous standard of safety testing starting now?